Okay, good. Well, welcome. Hello, everyone. Thanks for the opportunity to come and speak today to Women Who Code. I'm Ryan Fox, developer advocate here at Algorand, and I'm helping people around the globe understand our development platform, helping them with our SDKs, our APIs, and overall just getting them up to speed with how you can build blockchain applications using the Algorand protocol. So if we look here, so today what I hope to achieve here is to inspire you to dig a little bit deeper into blockchain development, into the Algorand protocol, and get out there and try this. We're going to spend some time looking at code. We're going to see some examples. We're going to actually see sending transactions to the blockchain, reading data back from it, using the mobile wallet. This should be fun. I hope it inspires you to come and build. All right, what we got today, I'm going to go quickly over setting up your development environment and then get into the 4A's of Algorand. And this is where we're going to spend the bulk of the presentation here on accounts and assets, applications, and atomic transfers, the 4A's. All right. Russ last week gave you a good overview of all of this stuff, and we're gonna go deeper here. And then upcoming, then on the 3rd of December, in a couple weeks' time, my colleague Jason will be going into a very, very deep dive onto applications specifically. So let's get into this here today. First thing that I want to do is ensure that you have your development environment set up properly, and that consists of 3 different components: setting up your IDE, your integrated development environment, setting up your infrastructure, the back end nodes and the API so that you can interact with the blockchain, and then ultimately selecting your software development kit, be that Python, Go, Java, or JavaScript, in order to be writing the code in the language that you're comfortable with. All right, so before we go any farther, I want to make sure that you are aware of the Algorand developer portal. This is going to be the place where you're going to learn and hopefully spend a lot of time getting up to speed. We've got great examples. Everything that you're going to see here today is available through the developer portal, and you can certainly use this search bar here at the top to look for anything that you're questioning or want to go deeper into. We'll want you to take a look at the blockchain basics here, which is a lot of the stuff that Russ covered yesterday, and then we'll get into the smart contracts and dApps and a little bit on tokenization as well. So you can get, oops, let's see if I can actually, yes, here is the website here very quickly. What's nice here is we've got examples that walk you through a little story with Alice and Bob. So we've got these 2 characters who we see throughout. Alice, she is a designer and artist, and she has the desire to create NFTs, or to essentially tokenize her digital artwork. And she's going to work with her friend Bob, who is a smart contract developer. And together they are going to iterate through that process of building out the contracts for that, digitizing the art, and then creating an auction so that ultimately Alice is able then to sell her non-fungible tokens for some algos on the network. So all of that's in here. Make sure that you're checking out the Algorand developer portal, and that's developer.algorand.org. All right, we are going back to the presentation here. We click on that. Yes. All right. This is a very busy slide, but this is what ultimately I'm going to show to you what you're going to interact with. Up at the top level, we're going to take a look at the infrastructure there, which has to do with the nodes and key management, and then this indexer to pull data out of. As you go down this layered system, we're going to get into the tools there in yellow, and ultimately get into the SDKs in that blue line there. And then each of those SDKs implement a client that will connect back up the stack into that infrastructure piece so that you can send transactions and pull data back from an indexer. And then ultimately, at the very bottom line, that's where you're going to be seeing writing your code, and we'll show you how to instantiate all those clients as well. So let's make sure that the next component is going to be that IDE. First thing you're going to want to do is set up your IDE. I happen to use Visual Code, so what I like to do to begin is to set up that VS Code extension here, and then it does all the code highlights and really helps with PyTeal and Teal. We'll talk about those languages when we see those. And the sandbox. Now, Russ went over this very briefly last time, but this is your infrastructure component. This is an Algorand provided tool that will provide these bits here. So inside of the sandbox Dockerized container system, you're going to get 4 pieces. You're going to get the nodes. That's all the networking piece. You're going to get the indexer, an ability to make queries of the data. And then you are going to get a key manager or a wallet. And then the last piece that you are going to get are going to be these REST APIs. So again, interacting with those 3 components up above. If on the technical side, on the right-hand side, the port numbers are exposed here for you so that you can have your software development kit asking on those particular ports for the information or sending the values back and forth between these components. We'll see that later. So the sandbox is an important thing. It's very easy. It's just a couple of commands. All that you need to do is go to GitHub and use your get clone command to find that repository, and then change into that directory. I like to set up an alias so that we know every time that I write out sandbox, it knows which application to call. And then we simply do sandbox up. And that'll bring up a private network. There are some additional ways that you can configure your networks. So you can also use sandbox up testnet, which is the way that I have configured mine today. So I'm going to be deploying and testing everything on the test network. You could also point it to the DevNet or to the mainnet, or you could just leave that off. And again, that will bring you up with a private network. And that's the way that we typically see brand new devs developing is using it on a private network first, and then migrating their applications to the testnet, and then ultimately to the mainnet. So you can always take it down and clean it. There are all sorts of commands that wires up goal, which is this command line utility for sending and interacting with the blockchain, all from the command line. We'll see a little bit of that today. And some important things for you to understand is that you would want to be familiar with the copy to and the copy from, so that when you're in your local environment, you are going to be writing your programs locally on your disk and then copying them to the container where they will then be executed within that private network or within that the infrastructure that's inside the Dockerized container for Sandbox. So a couple of additional commands that we will probably see today, and some other pieces for getting in there as well. The next piece for your development environment setup that you want to be familiar with is the SDKs. So we have 4 different SDKs that are available, produced by Algorand Inc., the company that I work for, and these are available in JavaScript, Python, Go, and Java. They're very easy to configure. For JavaScript, you can do an npm install. For Python, you can do a pip install. And for Go, you just use the go get command. For Java, we recommend using it as a Gradle package, and you put the dependency into your configuration file, and then it has the ability to now have the SDK of your choice installed locally on your development environment. If you would like to also see additional SDKs, we on our community page or on our ecosystem page, we have all sorts of great stuff here, including the SDKs. And as you can see, we have them for .NET, Dart, PHP, Rust, Swift, C++, Unity. We've got quite a long tail of SDKs available. These are built and maintained by our community as well. that should tell you a lot about what this picture is supposed to represent. Again, the infrastructure at the top, that's all the networking components. That's where the transactions live. That's where they're exchanged. And then we will use the tools such as Goal in order to interface with those, or we will use our SDKs and the clients therein to interface back up the stack. All right. That is a bit about the overview of what we have to offer here in the Algorand development environment. Let's get into talking about the 4 A's of Algorand, which are accounts, assets, applications, and atomic transfers. We're going to go deeper on this. Russ went into the overview last week. We're going to try to dive into this. First thing we're going to take a look at today are going to be our accounts, and we're going to go through 3 different types of accounts that the Algorand network provide: standard accounts, multi-sig accounts, and smart SIGs. All right, a little bit of cryptography here, but I'll try to glaze over that part, right? So a standard account is really the combination of a public key and a private key, a public key and a private key, which come from a random seed. And the important thing to understand here is that the public key is something that you can share externally. That's actually the address where people are going to send you assets or send you algos. That's the piece that represents you on the blockchain. And the private key is something that you will retain in secret and won't share it with anybody, because that is what actually provides the ability for you to sign a transaction and be able to interact on the blockchain. So public, it's okay to share it. Private, never share it with anybody. Keep it locked away and safe. All right, in code, what we want to see is the generation of this key combination and what they look like. So this is some JavaScript code here in these 4 lines. We are asking the Algorand SDK to generate an account, and it is going to give us back an account object, which we can then view the passphrase by using this method secret key to mnemonic and asking for the SK, or the secret key of that account object, and it'll print those both out. And it'll look something like this. So the address is this capital letter, this long string of letters and numbers here, and that again is the public key. That's what you can share externally, and then your private key is represented by this mnemonic, a series of 25 words in this particular order. The first 24 words here are actually, there's a lot of math behind it. Just, it's important to understand that these 24 words in this order, plus the checksum word, which is the 25th word, must be maintained in this order for you to use this account someplace else in any of your wallets. So you can move this around, just protect these 25 words, don't share them with anybody else. So let's go and see what this looks like in code. Actually generate some accounts, and we'll show you the randomness that happens here and how everyone is distinct. So if we come over here to some code, so we are going to take a look at that code that we had up there. We're using JavaScript, so we just are ensuring that we have the JavaScript SDK installed for Algorand, and that, of course, was easy to be done with a pip3 install algo SDK, right? You got to spell it right. Yes. Okay. So trust me, it's all there. And then we will then move on to running this piece of code. So we can use Node to do that, and we will generate the account. So again, I explained what it's going to do earlier, and we see that it gives us back an account. It was different from what we saw displayed there. And we also noticed that the mnemonic is different from what we saw before. So if we run this again, so we got back an account that starts with Alpha Quebec 3, and if we run this again, we will see that it gives us back one that starts with Sierra Kilo 3, and these mnemonics are different. So each one of these, each time that we run this particular script, this generate account method is using randomness to then generate a private key, to then convert it into this mnemonic, to then convert that into the public address that we are seeing here. So that's important. You can generate as many accounts as you want. There isn't any funding available in those, but you can use, especially on the testnet, you can use the Algorand dispenser in order to fund those. And that just looks like this. So if you copy that and you come over here to the Algorand dispenser by typing in dispenser.testnet.algorand, right? Okay, and you confirm that you are not a robot, and you type in your address here. It says that currently it doesn't have any algos in this account that we just created. However, we can click the dispense button, and voila, approximately 5 seconds later, this account will be funded. We're going to get back the transaction ID right here. We're going to also notice that the balance has gone up to 10. So this is a way that you as developers can quickly generate a test account, retain that private key, and then use that public address in order to get funded on the testnet dispenser. No, we don't have free algos on the mainnet, only on testnet. All right, let's go back to the presentation and let's take a look at what we should do next. How about if I explain a little bit about, let me just make sure, that seems like it went too far ahead. Just a quick sec here. Yep, that's right. Going on. We're going to take a look a little bit about what the account structure looks like for an Algorand account. So we saw what it looked like in code, and what we saw was the address piece, right? So we saw that long string of alphanumeric characters. The one that we saw was Sierra Kilo 3. That's the address. The other components to the Algorand account structure are assets and applications. And really what this is talking about is what is the authorized address, and what are the balances of the addresses, and what are the states of the applications that this particular account may have. So we're going to drill down into the asset side of that a little bit. So last time Russ talked a little bit about assets, or on Algorand, we call them Algorand standard assets, or ASA. And that's because there's a standard method for you to tell the blockchain how you want your asset structured. And we'll see some detail about that, and we saw some examples of that last time when we used the website algodesk.io in order to create some assets themselves. When we created those went onto the created side of this structure for the account. If and when that asset is transferred to somebody else, that will be on the held asset side of this account structure. So assets are organized within the account in two different sections, created and held. We'll take a look at, on the created side of that, what you will get when you create it is an asset ID. That's the unique identifier for your asset. You can give it any name that you want, and you can give it many different characteristics. But to the blockchain, the piece that's important is the asset ID, and we'll show you how you're going to use that asset ID for sending to others and for using it in different ways. Each created asset has two different sets of parameters. There are some mutable parameters and some immutable parameters. Similar words, but what do they mean? Mutable means something that you can change. And though these are a series of addresses that provide functionality for these assets, they allow you to claw back, or to manage the address so that you can change them around. We'll take a look at that in a little bit. And then there's those immutable parameters, meaning the stuff that you cannot change, will include things like the asset name, the number of units of the asset in total that have been created, the precision, how many decimal points beyond do you want to have for that one? The URL where this where it could identify some metadata of this asset in more general terms. So those are immutable. You cannot change them after they have been created. So these are the properties of assets that are created within an account structure. If you are holding an asset, then you will have something that looks like this: simply the asset ID and the balance that you have of that particular asset ID. So if I am to hold, say, the USDC token, which we saw that you can also get at that testnet dispenser, we would see the asset ID for that in my account, as well as the balance. And if you go to the testnet dispenser, you could get 100 of them. So then the balance would be 100. So then for each other asset that I hold, you would see the asset ID and then the balance for that particular asset. All right, let's take a look at applications and how they are organized within the account structure as well. Very similar at the highest level, right? So we have both created applications and opted-in applications, similar to held for assets. So we'll look at created. On the created side of things, here you are going to create an app ID. This is the identifier for the application that you are creating. And it will have two components. It will have programs and it will have state schema. So generally, what does that mean? So when you create an application, you are defining two different programs, and those tell define how the application will work when it's executed by the blockchain. And then the state schema defines how the application can store data within itself, within the app ID for a global state, or for local state, meaning values that it can store within a particular user's account, one that has opted in to use that particular asset, one that has opted in to use that application ID. We'll see that in just a moment, but let me go down the program side of things for a moment here and tell you about the two programs that each application has. I guess we've got it both at the same time. So let's look at the left side first. So for each app ID that we create, every time that we deploy a new application to the blockchain, we are going to define an approval program and a clear program. The approval program we're going to see is where the business logic is. It's telling the application how it can function, what it can do, and the business logic is there. The clear program is the one that allows a user to get out of it, to clear the data that they have stored locally within their account, to clear that out, to stop using the application. All right, on the right-hand side, we see the state schema. And the state schema is also defined and is immutable, cannot be changed when the application is initially created. And what it is defining is how much storage to allocate either on the local side within the user's space or on the global side within the application itself. So you can store a certain number of bytes or ints for the application itself and within the user space as well. We'll take a look at doing that in our example. All right, so that is, okay, so that was on the created side of the applications. Next, we want to take a look at the local state side of things for the applications that we are opted into. So if we opt into a particular asset ID, it will allocate some state storage space, which are simply key value pairs of data, right? So the application will have defined that you could say have 8 bytes, a byte field type structures, as well as 8 ints type data structures as well, represented as key value pairs. So the key would be a byte string that the one that we're going to use here is going to be a counter value and just a counter, and that would be a byte string that would be called counter, and then the value would be an integer value that we are going to increment. So we would just have defined it, or the application creator would have defined that as one integer type in the local state. We'll see that when we build the application as well. So again, this is the complete, over up here in the upper right hand corner, this is the complete structure of what an account looks like. So it has that address. Importantly, it has that address, that's the public address, and then it will have the assets that it has either created or holds, as well as the applications that it has either created or currently is opted into. And then below that, all of the data balances for assets and state data for the apps. That's the overview of what the Algorand account looks like. We'll take a look now at our second account type, which is a multi-signature account. And what that looks like is this animation here, taking three different accounts. In this example, I should say, we are taking three different accounts A, B, and C, and we are saying that two of them, the threshold, two of them are required in order to sign a given transaction from this new account that will be generated. So the combination of these 5 pieces of data, the 3 addresses, the threshold, and then the version number, will give us actually a new multi-sig address, D, all right? The important thing to understand here is that the multi-sig construction is used to help people protect their values so that they could create 3 different addresses and then store them independently. Perhaps they are 3 individuals, each having their own private key. All they have to do is define the order that they want their addresses to appear and the threshold that they want, setting that to up to n. So it could either be 1, 2, or 3, meaning that any 1 could sign, any 2 could sign, that's this one here, so any 2 of these, or all 3 of them would have to sign. The combination of that's going to give us address D, and if we reorder these, okay, A's down here, C's up there, all right, swap those 2 around, it's going to give us a totally different address. So the order is important. Same thing if we change the threshold here, if we made it just one of. We'll take a look at the example. Again, here's some JavaScript code to show this. So we are defining those 5 pieces. The version number, 1 is the only version number right now, but in the future we might have different versions. So we put that into this construction. The threshold, we talked about, that's how many of these addresses are going to be required to sign. We have the array of addresses in this particular order, A, B, C. And when we then use the multi-signature address, passing in all of those parameters, it's going to construct a threshold. Yes, it's going to construct the threshold, and it's going to construct the address here, multi-signature address. So the return will look something like this, right? So these addresses with this threshold will yield this address. Let's go see what that looks like in code. And if we come over here to calculate, we see that code there, and we are going to this one. Yes, and then we are going to go and run it. All right, so A, B, and C. All right, got it from the wallet. We'll move that down just a little bit. This is the important part here. So we have 3 different addresses here, and we had the threshold is 2, and it calculated this different address here. So Quebec Kilo Delta is what it calculated for this multi-sig address. You'll notice that it doesn't provide a mnemonic, right? Like we did when we generated the standard account. The reason is because the way that the multisig account will work to do the signature is that either, you know, this one here and this one, these two, A and B will have to sign together, or B and C, or C and, you know, any combination of those. It just has to be at least two of them. All three could sign if they wanted. Now, if we change this, so in the example, we swapped around A and C, right? So if we do that, paste, swap A and C, X, B, save. So all that we're doing is reordering those, and we're going to run this. So we had Quebec Kilo Delta. When we run this again, we are going to get Oscar Whiskey Charlie as that. Same thing would happen. We could leave the order the same, and we could change the threshold. So this would mean now that any one of them can sign. Doesn't matter who signs, but this is going to generate a different address, okay? So we would have to think about how we want to construct our multi-signature address at the beginning, because defining that threshold is important. If we only want one to sign, fine, but if we wanted two to sign, we could not put the value inside of this address and expect that it would require two. We would have had to define that at the beginning. All right, so that's multi-signature. That's a really powerful tool. That's our second type of account here on the Algorand platform. Next, we are going to take a look at our third and last type, which is called a smart sig or smart signature. And the components of that are going to be some program logic, which will be compiled down into some teal bytecode. And that is going to represent another address. So here we are, smart sig address F. And the way that that works is that compiled bytecode is then translated into an address string. The private key, it's not going to give us a mnemonic for this type either, but the private key for that is actually the execution, the successful execution of this program logic. As long as that program completes successfully, then value from this address can go someplace else, and that's called the logic sig, and that's why we call this account type a smart signature, a smart sig. This is what that looks like. If we make a simple program here in teal, which is the Algorand smart contracting language, we can say that if we create a program where the first thing that we put on the stack is 100,000, and this is micro algo, so this is 0.1 algo. And then we check to see if the transaction's first valid number. I'm sorry. Yes, and then we're looking at the and then we're going to do a comparative operator. So when I said that this was micro algos, I forgot. That's not the verification that we're doing here. The evaluation that this program is doing is simply looking to see if the transaction that is presented to the network is greater than 100,000, block 100,000, and that's what this is saying here. The transaction's first valid block number, as long as it is greater than 100,000, the transaction would be valid. This might not be the most secure address to put some value in, because at this point the Algorand blockchain has I think 16 million transactions, so anything from this address would be able to be taken out because it would execute successfully. So the way that this works is you take this program logic here, and then you compile it using the goal compiler, or you send it to an endpoint that will compile it for you. And you can see that that teal logic will then be translated into an address. And then you can use that logic signature, or a smart sig, we like to call it, and attach it to your transaction. to use in place of the signature. So within the transaction itself, it will expect that the transaction is valid if it has either a logic sig, like this one does, or a signature, and then it would expect the signature to be from the public key that was the sender of that account. All right, those are our 3 accounts. There's a little animation to show that. All right, signing those transactions, we are going to move along from signing those transactions and go straight into a really brief talk about some assets. Russ did a great job during the overview last time of giving you some great information about our assets, and he minted some as well, both some fungible tokens where the fungible token meaning that they're all the same. This is great for a cryptocurrency. So if you want to monetize yourself, your time, and you create a bunch of Foxbucks, and they're all the same, and anybody who has a Foxbucks can come and get an hour's worth of my time, that is great. I will redeem any of those tokens just the same. That's a fungible token. The non-fungible token, Russ also created one of those, and that was to represent something that is distinct, something that's unique. And this is actually the example that we provide on the developer portal with Alice, right? She's that artist and she wants to monetize her artwork. And so she creates this NFT using this specification called ARC3. And this is something that defines how you should organize the metadata for that particular asset. And the last type being a fractional NFT. And in the fractional NFT, we see that it still has a value of 1. There's only 1 that's created, but you can have a decimal point associated with it, meaning that you can have shares, typically that they're represented as shares or a fraction of that NFT, and you can have ownership of the whole. We see this frequently within the real estate market, where maybe you want to tokenize an entire building, and then somebody wants to have a share of ownership in that particular building, or a share of the rent for that particular unit. So that could be sold out as the fractional pieces of that NFT, and then for the value of the underlying asset, those holding any of those fractional NFTs, they would have proportionate rights to ownership of the whole. All right, again, lots of great demos that Russ provided in the first presentation. If you missed it, go back and watch it. I want to get into some applications at this time. Then we are going to take a look at smart contracts here. So applications or smart contracts on Algorand. I want to quickly show you what the organization or what the components are of this smart contract. So as we saw, the smart contracts are represented inside of accounts, and they are providing the logic program that defines how this application is going to work, the business logic for this particular application. That is going to, when it's deployed, it's going to generate a unique identifier. And in order to interact with this application ID, you're going to use application call transactions, a specific type of transaction on the Algorand network that only knows how to talk to applications. Those signed application call transactions are going to go into the execution environment. We call that the Algorand virtual machine. And within that, the programs will be evaluated, and they will perhaps create state transitions, meaning that balances may be updated or those key value pairs may be updated. And when that happens, ultimately those are then persisted within the blockchain because it is an approved transaction. They will commit those state transitions on the impacted accounts. If not, if the transaction, I should say, if the program logic fails, then all of those intermediate effects that could have happened to balance or key value state updates would be discarded. They would not be included in the block. They're not written to the blockchain, therefore they didn't happen. So that's important to understand here. When we talked in the initial about, you know, the blockchain is immutable. How do you do things? Go back and fix something if it's wrong. In this case, right, if it's evaluated up front, the logic is evaluated, and if it's wrong, or if all the arguments or the parameters that were sent to this application call were not evaluated properly, none of that happens. None of that gets committed. Therefore, nobody sees the state transitions that way. Only the approved transactions get written to the blockchain. So let's take a look at a demonstration application. We're going to do a counter application. It's very simple. All that it does is track application calls, and it increments a counter. So every time that the application is called, number goes up. And we are going to do this first for the application itself, for the global application, and then we'll update it and we'll do it for the local side. Then we can see who has actually called this application to increment it. All right, here we go. Let's go do some coding. All right, I've got my wallet here behind the scenes that we're going to use. So we've got to get the right code up here. Oh, it's actually this code, terminal. Oops. Come on, demo gods, be with me. Okay, why are you going so large there? Okay, here we go. Moving it down. Feels a little sluggish. We'll get there. So we've got this counter application. So in order for me to explain applications to you, I want to explain a little bit about what it looks like to write some programs here. So Algorand provides two different programming languages, Teal and PyTeal. Teal is the low-level language that looks a lot like assembly. We're going to see it, but this is PyTeal. This is a higher-level language that binds to Python, and Python developers will be able to see. I think we'll have a much easier time getting into and writing smart contracts using this initially. All right, I said that there were two different programs. There was the approval program and the clear state program. Now, this is the most basic application that you can design and build. If we are going to define the approval program as returning just the integer 1, all right, that will be the single value that will remain on the stack. And in the AVM, the Algorand virtual machine, that's what constitutes a successful execution of a program if there is just one non-zero integer value left on the stack. So if we compiled this, it would work. It wouldn't do anything, but anybody who called these transactions, the program would give a successful execution. Wouldn't do anything whatsoever. All right. Important things to understand here is that when we can use the PyTeal library in order to compile the program, and we are using this as the application as the mode for application, because that's where we want it to be an application. That's not a logic signature. I'm sorry, not a smart signature. And we are defining to the compiler which version of Teal we want it to use. Here, we're the most recent one, Teal version 5. All right, so that's a very basic one, but really if we want to get into understanding how to write these, let's do something a little bit more interesting here. So we have a boilerplate template that we like to have our programs use, and it uses the condition method here to say for each of the types of transactions that it could encounter, create a handler for each one of those. So the first one here, so condition just says, check all of these. If it's one of these, go and do it, go to the handler. And if it gets to the end and it didn't find any of the transactions, then it's an error, and then it will just, it will fail. All right, so what we want to do for the creation is to have, to check that the application ID is actually int 0, which it is, meaning that the application ID is 0. That means that there is not actually one assigned yet, and that means that we can use this handle creation. If we saw that the transaction type was opt-in, we would go to the opt-in handler, and so on. So let's go take a look at what it looks like to handle that creation. So what we want to do, if they come to the first condition and they go here, we're going to now use a sequence, which just means take a series of logic, take a series of commands and process them sequentially. So here what we're saying is, for this application, we want to put some bytes into a value that were called counter, I'm sorry, into a key called counter, and the value that we are going to store is going to be the integer of 0. So essentially what we're doing, this is the initializer, right? When we deploy this application, we are going to hit this creation handler, and we are going to write some data. We're going to put some data into a key called count, and then we are going to return 1. So again, this line number 6 is about writing state to the global side, and we are then, the second command that we're doing in that sequence is to return the value, the integer value 1, so that then this program will succeed, but it will actually do something this time. And that can only happen one time. That can only happen when the application ID is 0, and when this succeeds, the application will be created and it will actually return an app ID, so you would never be able to come back into this application again because it would have already been created. All right, so then we can handle the others that are in here. So here we're showing just very quickly that we can now handle the opt-in. For this, we're not going to allow anybody to opt into this one because we're not using it, or nor we're not, since they didn't opt in, they don't need to close out. There's nothing is going to be updated on the local side. We are going to allow them to update or delete this application because this is for testing purposes only. Typically, we want applications to actually end up being immutable, and once the application is to a point where it's set, we don't want people to be able to change them, or as a user, I should say, as a user of an application, I don't want somebody to be able to change it. So then we would have the update app handler returning int 0, and then anybody who tries to update it would then fail to do that. Typically, we also do the same thing for delete, because you don't want to be participating in an application and then have somebody take it away from you. So we want that to also be set to 0 in most applications. The last thing here, we need to get a handler for the noop, and this is the one that does the bulk of what we want it to do here. And in this case, what we are going to do for our noop, oh, here it is. Yes, it is a sequence, and it's using some scratch space. So it is taking the value that it gets from that key called count, and it's storing it into a variable called scratch count, okay? And that's of type uint64, all right? So now we have this value stored. First time that we call this and the first time that we run through this, it will be 0, of course, because it was just initialized. And then the next thing that it's going to do in the sequence is to put into the value, into the key count, we're going to put this in there. And what we're going to put in there is going to be loading that value 0, and we are going to add the integer value 1. So of course that will be 1, and then that will be stored as the value for the key count. And then the third thing in the sequence will be, we will return 1. So that will be positive. This will then update that. So every time that somebody calls this every time that somebody calls this application, this count value will be incremented by 1. All right, prove it. Let's see it. All right, so what we've got here is some code that does all of that. This is the complete code to do that. And what we are going to do now is ask Python to execute this code and ultimately write out the approval program and the clear program. So let's do that. Am I in the right? Yes, Python 3, and this is 1.1 define programs. All right, here we go. It's very fast. This is teal. All right, this is the low-level Algorand language. Like I said, it looks very much like assembly. What we have here at the very top, okay, so we see at the very top, we see Pragma version 5, right? So that was, we told the compiler, hey, use version 5 of teal. So it did that. That's what that means. And then the next thing that it does is says, hey, if that transaction application ID is 0, right? Then branch to 12. So that was our first, remember, the very first thing that we had in our code was to say, check for that. And if it does, it branches to 12, and 12 is down here, and it just says, right? Define the count, put the value, or add the integer value 0 onto the stack. App global put takes those, consumes both of those two pieces of data that are on the stack and writes them into the count, and then it puts int1 on the stack, and then it returns. And the next thing that it does, I will quickly show you that this was the noop one, right? So this is what that code looks like all the way down to here. So if we got in there, it's saying, right, get the count from global, store that at index 0, right? So now we've stored that value. Now we are going to put back onto the stack count, and we are going to load that value. We are going to then put 1 on the stack. We're going to add those two values together, and then we are going to put the return value back into count, and then we're going to return 1. All right, so this is what teal looks like. Like I said, it's very assembly-like. Some people love it, and some people think that it's a little hard to read. The clear program was very simple. Again, all that that's saying is putting a 1 on the stack and being able to return it. This will always pass. This is why we use this for the clear program, because we want people to be able to exit out of the application if they would like. All right, now let's deploy this. All right, so come on Python 3, and we're going to 12, right? Okay, so we're going to deploy this application. Oh, maybe we should look at it before I actually do it. For this, the important thing to understand in here is that we are going to, we're using the Python SDK for this one, and we are going to get the client, we're going to get some transaction piece, we're going to get methods for mnemonic and account. For this, like I am putting into my code the private key, the mnemonic. This is a great way for testing. This is obviously not what you would do in production, but here we have my long mnemonic is there. And then we are going to create a client. And this is hitting the sandbox. So it's using localhost and the tokens. This is all the default stuff for sandbox. My sandbox is connected to testnet. So that's where these transactions will go. We've got a number of helper functions. I'm going to skip over those and get down here to the main, where what we are doing, oh, that's the CreateApp one. Oh yeah, actually this is important. The CreateApp piece is really what's important for this, because what we are saying here is that we are defining our sender as the, from the private key, right? So it can calculate what the account is. And then it's saying as long as the transaction type is the noop, then create a, with the client, get the suggested parameters. So this is going to go to the network. It's going to make a call out to the blockchain, and it's going to get back the suggested parameters that it needs in order to create this unsigned transaction here. So we are now going to make a transaction of application create transaction type, and these are the pieces that it needs. So it needs the senders, those parameters, that on complete value, and the approval program and the clear program. We're going to read those from disk, and then the local schema, the global schema and the local schema. And those are defined up here. We talked about this when we were looking at the when we were looking at the account overview. So we need to figure out where we defined that up here. That must have been up here at the very, very top, and I must have skipped over it. Come on, where did I stick it? Did I stick it in the main? Maybe I stuck it in the main. Ah, here it is. Yes, oh, because we're passing it in. I see. Here we are. So, so we are saying in the main, we are saying to start a client, get the private key from that mnemonic, and then we are defining then the application storage space. So for global, we are saying that this application will only have one global integer key value pair. It won't store any bytes, and the same will be for local. Now, initially, we're not using the local bytes. We don't have any of that defined in our program yet, but we have to define it now for future use, because this state, the state storage is immutable when we create the when we create this application. All right. So the next piece that we're going to do, so we define that piece, and then we're going to compile it. So this is going to take our teal program, and it is going to then compile it into bytecode that will actually be interpreted by the blockchain. So that's what this compile program here does. And then we are going to deploy it. Okay, so we made that transaction up above. The piece that we have to do is sign it, and then we broadcast it to the network. So that's what we are going to do here. And then one thing that we're going to do is in this, when we get the application back, right? So when we get a successful create, it's going to return us the app ID, and then we're going to write that to disk, and then we're going to be able to read that in with our next scripts. Okay, here we go. Let's deploy it. Nope, gotta put that here. All right, there it goes. I'm going to not save that. All right, so we are making a brand new application. It is this, and I'm going to copy that application ID. As you can see, that the global state is now set to 0. And the next thing that we are going to do is then come into our mobile wallet, and I've started this up. So this is the Algorand mobile wallet. I have set it to the testnet by going into the developer settings, and I can switch between mainnet and testnet. All right, so you can use your Algorand mobile wallet on testnet or mainnet. We are using this on testnet. So the next thing we are going to do is take a look at our application here that we are working on, and we are going to take a look at our demo. And the first thing that we are going to do is connect our wallet. And the way that we do that is we click the button that says connect your wallet. And then on my screen, I'm going to click this little icon here to scan this QR code that pops up. This will make a, where is that? Yes, there it is. All right. And this is going to make a connection between my web application and my Algorand mobile wallet that I have in my hand here. All right, so do I want to do this? Yes, I want to connect. And which account do I want to connect with? I only have the one account, so I'm going to select Alice. And what we see here is that it makes a successful connection, and it populates our address here that matches. If I guess I have to push that here. If I show now that we can see that the address is the same on the mobile wallet as it is as referenced in the application. Now we're going to set up this demo, and we are going to paste in the ID for our application that we just did. And now it's connected to the app ID. Of course, the global counter is still 0, as is the local counter. So let's now try to do the global counter. Let's try to click the button that says global counter increment. On my mobile wallet, we see that it popped up a transaction. We can take a look at that transaction. It's going to this particular application ID. We can see that the transaction type is a noop. It has a small fee. It has some data as well in the notes field. Do I want to approve this? Yes, I want to confirm that. Am I sure? Yes, I am sure. All right. So we'll see here that the signed transaction is now waiting on the network to approve it. So it is going through and executing that the program logic in the approval program, and it was successful. It returned, and it also updated then the global counter. If we want to do that again, we can certainly do that. Can anybody guess what's going to happen? Yes, of course. It's going to increment the global counter value to 2. Extremely exciting, I know. All right, let's do something more exciting than that. And that is actually the next part of our presentation, to talk about atomic transfers. And atomic transfers mean that you're going to have a group of transactions that are either all going to fail or they're all going to succeed together. So we put a transaction array, an ordering of individual signed transactions, and we send that to the network. The network receives those, and it evaluates them in order. If any one of them fails along there, all of them will fail. If they all succeed successfully, all of those state changes, balance transfers, all of that will be committed, and all of those transactions will have been successful. So that's what atomic transfers is. It's very powerful, especially with applications, because you can then enhance your simple counter application to track what we were doing before, but also add a pay to call. All right, so now that means that what we need to do is not only have that application call transaction, but we also need to have a payment transaction as well. So let's take a look at what that might look like in code. All right, we've got to update the application. You gotta spell it right or it doesn't work. So we've got this update programs and oops, let's take a look at what we're actually updating here. 21 approval. The difference that we are doing in this program here is to add into the noop handler what we originally had was we just had this sequence piece here, right? Yes, all that we were doing before was just incrementing the counter. But now what we want to do is we want to make sure that we actually have two transactions coming in. So the group size of the transactions coming in is equal to 2. We want to make sure that the first transaction in the 0 index slot is an application call transaction. We want to make sure that they are paying a particular address. In this case, this is the dispenser, that testnet dispenser address that gave us the 10 algos at the beginning. We want to pay them back. So as long as they send any amount, just 1 micro algo will be fine. As long as it's greater than 0, that's fine. But all of these conditions here must pass, because this is within the and. So it says, and all of these things, then do this sequence, which will allow you to increment the counter. So that this is combined. This is now saying that that atomic transfer is required in order for this application call to complete successfully. And we'll see that. So what we are going to do now is deploy that. 322, update the application. Away it goes. So because we had defined that this application can be updated, it's updating it. Oh, that's actually one other thing that oh no, that's the next one. Yep. Okay, so there it goes. So it has now deployed it, and we now see that the application count has gone up 2. So I think that we've got some people doing the play at home game. That's good. We now have now deployed the new one. So now we can come over here. Oh, yeah, actually, we did that twice. Yeah, that was me. I did that twice. Okay, so now we come on over here. We can make sure that we are unlocked on this. And we are going to, it's the same one. But what we need to do now is pay an increment. Oh, but we have to update this one. You know what? I forgot one thing. Pardon. We want to actually do, we actually want to add in the, come on. We've got to add in the local state, and that's this one here. Come on. We want to do the 31 update and the 32. Oops. We want to update the application this way. And I forgot to add the local part in, and I forgot to explain that, but very quickly, in addition to checking the pieces here for making sure that we're sending the atomic transfer, although those 2 transactions, we also want to make sure that we then are updating the local piece. So it looks very similar what we're doing here, but importantly, we are updating the local space here for something called calls. So we have global, we have counts, and local, we have calls, and each time that the user calls it, they will now update their local as well. So that is that. We need to, what did we just do? We updated it. So now we need to, it's been updated. So now we need to call it. Well, one thing that's important here is that Python 3, this is going to make an error. 33. Oh no, that is up to 33. 33 is call. Okay, so we're going to do this at the command line. All right. And what it tells us is that it's failing because the user did not opt into this application. Okay, so this this user is required to opt in to use this application before they can call it, because that's what we put in, because it has local state allocated. So in order to do that, we have to run this opt-in command. We will now quickly opt it in, and it will say that it's successful. And now if we run that call to increment and pay at the same time, it will return hopefully 3. Yes, all right. So now we have actually paid to do that. We should be able to do that over here as well because we're already opted in. We should be able to pay to increment if my demo app is working here. Yeah, I guess I have to copy this back in. Come on, demo gods, be with me. And I know we're getting close to being out of time, and I am trying desperately to make this all fit and explain this. We have 3 and we're already opted in, so we should just be able to hit the pay to increment. And we have to look, of course, over here, because that should have popped up on over here for us to approve the transaction. Come on now. All right, well, we'll do it from the command line because sometimes it doesn't want to work. Well, we saw it working on the command line. The last piece that I wanted to show was it failing if we do a, if we try to call the application with just, like we did in the first one, where we only send it one transaction, where we just send it the application call transaction, this will fail because it's saying it's evaluating the program which we have installed right now, and it says, hey, the global transaction doesn't, the count isn't 1. It's that's empty. It's supposed to be 1, but you only sent me, or it's supposed to be it's supposed to be 2. You're supposed to, the program logic said up here, right? It said, make sure that you are sending me at least 2 transactions, but you only sent me 1, so therefore I'm going to reject this transaction. I am not going to increment the counter. And that we can definitely see here. It has not incremented the counter. So the only way to increment the counter is to send both transactions. And that is this. And we can increment it one more time. And in code, I want to show you what that actually looks like once that's done. Okay, so that goes up to 4. But what's actually happening in code on that transaction is spinny wheel of death. My computer is going slow. Is we come down here and we want to look at what's going on in app call, and we are noticing here that we are making a group transaction. All right, and the way that we are doing that is we are creating 2 unsigned transactions. We are making the app call transaction, and we are making a payment transaction. And I guess we didn't see the payment transaction here, but what we need to provide there is the sender, the parameters, the receiver, and then the amount. And so that's where we were putting in the receiver address as the dispenser address, and then the amount we had set just to 1. Okay, because so it could be anything because our program is only evaluating that it is greater than 0. So and then once we create those 2 unsigned transactions, we group them together using the calculate group ID method. We put them in a particular order, similar to what will happen with our multi-sig accounts. If we get the order different, it'll actually calculate a different group ID. So then we put this group ID into the application call, the same one into the payment transaction. That's how the evaluator, the ABM then is evaluating these transactions, and it knows as long as those identifiers are together, are matching, then they are part of the same group, and I will put them in order that I receive them. And then it will execute them in the order that's received. So then we have to sign each one of those transactions, and then we send the array of transactions, both of those, in this order, the app call transaction and the sign pay transaction. All right, and then we just wait, and as we've seen, it works. So that is atomic transactions, and that is represented there by our counter application. All right, we made it. Well, how exciting was that, right? Developer environment setup, we went through that. We showed you how to use Sandbox, got you familiar with the various SDKs. We use Python and JavaScript here today, but you could certainly use Java or Go as well and do exactly the same things if those are your languages of choice, as well as you could go out to the developer portal and you could see the other available SDKs and repeat those. We focused on the 4 A's of Algorand: the accounts, the applications, the assets, and the atomic transfers. I hope you have a better understanding of each of those today and have the code then available to use those. I want to remind you, we took a look at the developer portal. Scan that QR code, or just go to developer.algorand.org and you can meet Alice and Bob, see the demos, try it out yourself. In the upper right, there is actually a way to get to the Discord server as well, or you can just go directly this way. That's where we're there to help you, and we've got lots of interactive content going, or conversations going on there in all sorts of the different channels here. So the developer tools, the applications that are being built, all of the community is there. We welcome you there. So thank you so much for joining me here today, and I look forward to your questions now.
Hi, Ryan.
All right. Hello.
Hi. Thank you so much. That was very insightful. And we have had a lot of questions that came in, and I think Ben answered most of them.
Oh, that's
There
good.
is one question here. It's an open question that hasn't been answered, which is from an anonymous attendee. So the question is, what are some dApp ideas for people looking to explore blockchain or Algorand?
Right. So each application that you deploy will get a distinct application ID. Typically, you're not typing in the application ID into the web interface like I was. Typically, the dApp provider or the web provider is hard coding that behind the scenes. Mine is more dynamic because I'm changing them all the time. So yeah.
The question was, what are some dApp ideas?
Not IDs, ideas. Oh my goodness. All right. Well, to finish my thought, because I wasn't explicit when I was showing my user interface, I was dynamically putting in the application ID. Typically, the developer will put in the application ID and have that hard-coded because it's their application. If you want to find interesting applications, I will certainly encourage you to go to the developer portal and go to that blogs page, which is the ecosystem page, and in there you will see a list of interesting applications. So for ideas, what are some, so the question was, what are some interesting ideas that applications can be built on? And I think the one of the best places to look would be at the algorand.com website, and there is a use cases page there as well, and it gives a listing of most of the applications that are in development or are already built on Algorand. So I'm trying to quickly get the use cases page, featured use cases. Here it is. Copy, and I will paste it in. I'm not sure if that's still what are some ideas. Okay, type answer, paste, send. Got it. There we go. So if you go to the algorand.com site for use cases, you can see some of the very interesting things that have been built or are being built. Ben, did you have any additional questions that you wanted me to either repeat on here or ask in general that you saw come across?
Somebody was asking about the code that you have for PyDApp counter. Is that something that you can make available on GitHub or something?
Yes, absolutely. This will be available on GitHub, and it will be in our DevRel repository. So the Algorand developer relations team, we have our own repository on GitHub, and I will post it there. And I owe you the slide deck for this one. I forgot to save it up ahead of time, so I will make that available, and check the show notes in the recording here, because it'll be pasted in there for you. All right, so everybody will be able to have the slides that I provided, along with links to the GitHub code, so that you can try this out and replicate it for yourself.
Great. That would be amazing. Thank you, Ryan. I was just
Yes,
about to
you're
ask that. That'll be good. So yeah, if you can send that across to Gracia.
Yes, of course.
We'll make sure to add that to our Slack group. And then
Good.
also, yeah, the YouTube description as well.
Great. And then reminder, so this was the second of 4 Algorand's focused talks that we've been giving. Again, Russ gave one a couple of weeks back. The recording should be up for that one. And then upcoming on the 3rd of December, we'd like you to take a look at the Women Who Code site /blockchain, and there you can sign up for the event that my colleague Jason is presenting, and he's got one that is that'll go into even more detail on applications and what you can do, some more advanced applications that he's going to show being built. And then on the 9th of December, then we have a partner, an Algorand partner, a company called Reach, and Jay will be speaking about the Reach programming language, which is an even higher level language, looks much more like JavaScript, that allows you to design your smart contract, the back end smart contract code, as well as the front end, or the user interface side as well, simultaneously. And a very powerful programming language is Reach, and encourage you to check both of those on December 3rd and December 9th. Sign up at womenwhocode.com/blockchain.
Amazing. Thank you, Ryan. That's just about what I was about to share there as well. So thanks, Ryan. There's also meet and greet tomorrow. We have an event for the blockchain as well. It's on the 25th. At 6 p.m. EST, actually 2 days time. We're good move for that. So yeah, so that's another exciting event that we have coming up in the blockchain Slack, like blockchain track as well. So you can check that out. Like Ryan said, you can see the Algorand series there as well, series 3 and series 4 at womenwhocode.com/blockchain. If everyone can hold on for another few minutes, I've got some closing slides to go through. So I will start sharing my screen. Let's see. So can everyone see okay?
Yep, they look fine.
Perfect.